morning. It's time to start, otherwise we will not have time to reach our boat trip in the afternoon. So before starting, just one message. So we start exactly at 7:30 on the place Lindholmenspiren, which is a quite big, difficult name, but it's very near here. So just 200 meters, something like that. But I would propose start from here, maybe 5:20, and go to the place. So maybe 5:15, it's even better. So, and remember two things. So what is valid in Sweden? Time is accurate and precise, so no floating point, it's accurate, exactly. And the second, that there is no bad weather, there are just bad clothes. Okay, so take something that you will not get cold, and but we will not have a long walk there. We are going by boat, the boat is closed, and then go to the restaurant, so no problem, and back by buses. And in the meantime, we will get warm by some beers or wine, so there is no problem on the way back. Okay, so come on time. And now, let me just set up the... Yes, so I would like to announce and present and say that I'm really happy. Really, we have an amazing keynote today, and that's Francis Paulisch, senior, I have to read this, a senior principal key expert for software and digitalization and Siemens Corporation technology. Francis Paulisch is expert at Siemens, working with the new trends and changes in industry towards the digitalization. But Francis is also very well known in the research community, active in many conferences, and also a chair of the advisory board for IEEE Software Magazine. So it's a pleasure to say hello to Francis. So Francis, please come. And so let us give an applause.
Okay. So thank you, Ivica, for your kind introduction.
Yeah.
Great, thank you. So as Ivica said, I'm from Siemens Corporate Technology, and we have a lot of activities in the area of improving in the area of software and digitalization. It's very, very important to our business. And I really appreciate the opportunity to come here and to share some of our activities with you. The topic of software architecture and also system architecture, because we're not just in the software area, we're getting more and more software and digitalization, but the topic of architecture is extremely important to us. This slide shows an overview of the different divisions of Siemens and also the healthcare area. Siemens has actually also been in Sweden for almost 125 years. So Siemens actually started in Sweden in, I think, 1893. And there's a lot of activities associated with these business units that's actually here in Sweden, even in Gothenburg. So, for example, the mobility here mentioned at the bottom, which does things like trains, for example, the buses, the bus 55 that comes here to Lindholmen is an electric bus, which also uses a lot of renewable energy, so it's very low emissions, also very quiet. So this idea of sort of sustainability is also a sort of a very important topic for Siemens, and also we very much welcome that a lot of the Nordic countries are especially active in this area. Also in the area of mobility, there's a very big and important project called the E-Highway in Sweden. So here in this E-Highway we have a cooperation with Scania and I think also Volvo for doing this E-Highway. Building Technologies is doing a lot in the area of efficient buildings. So this is, for example, there's a city called Vellinge in the southern part of Sweden that has all of their municipality buildings done in a very highly efficient way by our Building Technology divisions. Power and gas. up at the top right, is one of the most power and gas and the power generation services is an area that's very big in the Nordic countries. So like the Vattenfall hydropower plant is done here. A lot of wind power. Digital factory that I mentioned here on the other side, this is also a very, very large part of the software that we do at Siemens is in this digital factory. One of our sort of software, very strong in the software area divisions, the Siemens PLM, is in this part of the company. So many of the automobile or aerospace companies, for example, know a lot of our products in this area that do a lot of the simulation and modeling, the topic of digital twin. So you may know the products like Technomatics, Teamcenter, Process Simulate, where you can do a lot more simulation and then not have to produce so many real prototypes and thereby save a lot of effort and money. And so these tools are, and ideas behind these tools are very important to be able to do more model-driven approaches. Also, process industries and drives, a little bit like the mobility example I started with. The process industries and drives have, for example, in Norway in this case, the very first electric car ferry that's also done, really recharge the batteries based on renewable energy, and so it's also a very low emissions and low noise approach. And a lot of the tenders that are given out by the municipalities in the Nordic countries also require such. And I think that's a really good approach overall in the whole world, that one really puts a lot of emphasis on these sustainable topics. And finally, in the area of healthcare, we call them now the Siemens Healthineers, is their name. There's also activities here. For example, there's a special university here where they do a lot of minimal invasive surgery through these high-tech products. So it's like angiography or magnetic resonance imaging that can be done so you don't have to do major surgery to address some of the challenges that people might have in the healthcare, but you can also do this via more high-tech approaches. So in general, we're doing a lot more individualization in our systems and also doing this a lot faster. So those are two really major drivers that we have that are really pushing a lot of our software approaches and our methods. And I think this is probably common to a lot of the companies that you are representing, or a lot of the research activities that you are probably doing if you're working at universities or research institutions in this space. So we're having a lot more flexibility, and the design is becoming much more important. We have individualized products, but we want to be able to make them efficient. So we need to think about product line engineering and these kinds of topics. So you have lots more variance, time to market, and flexibility and speed is very important. So the topic of cars is sort of a common theme throughout this keynote. We have, for example, on the cruise control, you have passive cruise control 10 years or so ago, and then you get into more adaptive cruise control where it adjusts according to the distance to the car in front of you or truck in front of you. And then you get into more active cruise control where the car itself changes the lane as needed, and then next step would be autopilot, or next step beyond that would maybe be actually having driverless cars and mobility, as a service. So there's a lot of very exciting things that are going on in this space, right? The technology is making more and more possible, and we need to think a lot also about what are the business models behind these topics? How can we take advantage of all of these opportunities? So you'll see sort of the car theme a little bit through the talk. Germans really like their cars. We have our Autobahn. I'm not actually German, I'm Canadian, but we have a lot of importance in the car industry, as I think you do here also in Sweden. And thus we have also the Autobahns, is probably the only place in the world where you can have unlimited speed. So because of all these trends that are coming, we have additive manufacturing, intelligent automation. There's a big difference in how the products are being built and how these ideas come to life. There's a lot other different techniques that are now being used to do innovation. And of course, it always depends on the situation that you're in. If you're working on the next generation of a product that's already very well established in the market, then you would maybe do maybe just a smaller innovation and try to figure out how to make some additional features that are of use to your customers. But there is also the other extreme where you're working in a totally new space and you have much more freedom to do more radical or disruptive innovations. And of course, the techniques that you apply in each of those cases is going to be different. So it always depends on the situation that you're in. So there may be more things like crowdsourcing design. We do a lot in the area of ecosystems. For example, we have our MindSphere topic, which is sort of a cloud-based, open operating system for Internet of Things. And so we do a lot in the area of how do we deal with partners, how do we work together and co-create and collaborate on a lot of these topics. Also, the topic of analytics that is mentioned on the far right is very important. How can you use the data that you have during the development and also in the operation of these systems to further improve your product, to further offer maybe some features in the product, to take advantage of this vast amount of data that we have from all of these products. So I hope that some of the ideas that I will be describing are also of use in your own context. So because of all of these drivers, we have a lot more uncertainty in the current market. You know, things are happening so fast, and it's much harder to predict. And to be honest, a lot of the development methodologies that we've been teaching, I don't know, maybe teaching when you went to school to learn software engineering, a lot of those are maybe more old school now, right? They're more based on sort of more physical engineering, that you can plan everything up front and then try to keep any kind of change out so that you develop your system on time. And we're experiencing a big change to being able to adapt to those changes, right? If we can master the changes, then we can actually be much more successful. So we shouldn't necessarily try to keep all of those changes and that uncertainty out. We need to find a way to be able to work with this uncertainty in a positive way and to take advantage of it, because it not only provides challenges, but it is also provides a lot of opportunities. And I sort of like this quote on the right here, under the uncertainty ahead. So walking on water, you know, like Jesus, and developing software from a specification are easy if both are frozen, right? So we have these innovation cycles that are going very fast. We have this increasing complexity, and the systems are becoming much more interconnected also. And we Siemens have a lot of the challenges, I suppose many of you do also, that we're not in a software-only world, right? We have a lot of mechatronic systems, a lot of hardware that's also connected to that software and works in an integral way with that software. And so in a software system, you can quite easily maybe undo something. But if your software is controlling a physical process, it may not be possible to undo. And so, of course, we have to be aware of that when we design these systems. So we're in an area that is particularly challenging, I would say, in this regard. And also, a lot of the sorts of systems that we develop are very long-term use. It's not so easy just to say, okay, next year we'll have a new version and update everybody, because a lot of times, if we're developing a train, for example, it typically has a lifetime of maybe 20 years or so. So we have to think in advance how we can maybe try to also update that train. How do we take care that this is still a valuable product over this long period of time, right? So these are some additional challenges that we have in a company like Siemens that has more long-term products with also associated with hardware, sort of more embedded systems. There's also additional challenges that we have here that we're often in sort of more mission-critical area. So also in the healthcare area, for example, there's also safety-critical issues and so on. So we're in an area that has a lot of challenges. So a lot of the sort of software-only methods are highly relevant for us, but we sometimes need to have a special take on them to be able to apply them appropriately in the sorts of environments where we live. So this is an overview of the topic of complexity. So I think many of you know the Kinefin framework by David Snowden and Mary Boone on the right. It's sort of a system visualizing complexity in different kinds of complexity. It starts here at the bottom right with this simple approach. These are things where you have more. It's easier to see the cause and effect between, see the effect of a particular cause. So you can apply management approaches that are a little bit more like command and control. You know what the outcome is going to be. And as you move around this from sort of anti-clockwise to more complicated, complex, chaotic, it gets increasingly hard to predict. So there's things on the left side that are maybe like the weather, you know. Did Antonio know 2 weeks ago whether we're going to need the umbrellas or whether we're going to be okay, right? There's no bad weather, there's just bad clothes, as Ivica said. But this is much harder to predict, and it's very important to be aware of which situation are you in. If you're in this chaotic environment or even in this complex environment and you try to do your project planning and your structure of your projects in a command and control kind of way, it's not going to work well. This is sort of why also there's an overall trend to more empowerment of the individual teams, the topic of lean, the topic of agile. These kinds of approaches work better than those sort of standard management approaches in these more complicated, complex environments. So over on the right, there's things like you can always take advantage of best practices, but they're not maybe quite so transferable in the areas on the left. Many of you that perhaps know our work at Siemens know that we have an architecture program, so we have a curriculum focused originally on software architecture, but also have more recent roles addressing also system architecture and also a new one on the area of test architecture. And the system architect program has a view on complexity here that has some of the topics that's listed here on the right of the slide, some of the things that contribute to the complexity, because we have to be aware of this in order to design our system architects in an appropriate way. And of course, this also includes how does the system and the software interact together? Is there going to be synchronization points along the way where we can really then try out the combined product in a prototype and so on? And our test architect program, by the way, is set up so that it focuses not only on the testing of the product itself, but also how to set up a whole test infrastructure. So I'll be getting in towards the end of the talk on the area of DevOps. And this is in the area of DevOps, it's also very important to take into consideration the infrastructure in which you are developing and operating the system. And this also includes the topic of testing. And so it was very appropriate that our test architect program actually already from day one addresses not only how do you test the product, but also how do you go about doing the architecture of the system that takes care of all the testing and all the different test methods, and how do you go about setting up a huge amount of automated tests and the right risk-based approach to testing or model-based testing. So, as I mentioned earlier, the topic of change is a very important one. It's not only something that is a risk that we need to address, but it's also one that it also provides a lot of opportunities to us. So I thought this was a sort of a nice picture here with change and chance. There's really only one letter difference between them. So it really does open a lot of opportunities. And we often have various well-known software engineering gurus come and hold sort of trend forum workshops for us at Siemens. We had Mary Poppendieck not long ago, and it reminded me of this topic, learning to surf. So there's a quote that Mary has in, she gave at the ICSA 2013, that instead of learning to surf, the conventional organizations try to control the waves, and this almost never works. So you need to get away from this command and control. You've got these waves, right? Like I was showing in the Kinefin framework. You've got things that you can't control, like the weather. And traditional organizations that have a more sort of particular management style, they try to control those waves and say, we're not going to let any of those changes. We signed off on what this requirement spec was going to be 2 years ago, and darn it, we're going to finish it as planned. And you can't work that way anymore, right? You have to be able to master those waves and learn how to ride them and be able to flourish in this new kind of challenging environment. And it's not easy, and it's a big cultural change in your companies. So in the abstract for the keynote, I mentioned the topic of balance. So it really depends on where you are. Are you in this more product development that is sort of just the next generation that's coming up, or are you more in this disruptive space? And so there's a lot of things where you have to take into consideration where you are to know what is the most appropriate method. So there's of course no one-size-fits-all to any of this, but you have to have the right balance. How much discipline and how much agility do you have? Especially here in the software architecture community, how much upfront architecture do you plan for and put into your systems? You know, right back when the agile topics were first starting, they were saying, you know, you don't need much architecture, right? And we had a lot. You had a lot, especially Philippe. Also, you had a lot of activities there. Of course, you need a lot of architecture up front, the right amount of architecture up front to be able to provide the necessary stability. So you need to have the right mix. So you have to plan ahead, but not plan in too much detail. So a lot of like agile development, it has more of a big picture, but you plan the one sprint in detail, but you're wasting a lot of effort if you plan, you know, the whole 1-year project into you know, day by day detail, because that stuff in the other n-1 sprints is not going to come the way you expected, and so you might as well save that time on planning in that level of detail and do something better with that time. So Jim Highsmith has also a similar view on this, that it depends a lot on the mix of what you can plan to adapt, and that you have to anticipate certain aspects. So you have to have a good feel for what you can plan ahead and what not. And this picture here also symbolizes, in the area of software architecture, that you need to also have the architecture of your system set up in an appropriate way. If you have a huge monolithic system and you have to develop it you have to, you know, design, compile it, it's all in one big ball of mud, right? You're going to have a much harder time working in this kind of space where you want to be able to have more flexibility and change one thing out and replace it with another. You're not going to be able to do that if all of the system is so very, very dependent on each other. So you need to think about that beforehand, or if your systems are already like that, try to migrate them to a more component-oriented or microservice-oriented, some kind of chunks that can be more independent of each other. And so this is sort of showing the monolith on the left and the set of smaller chunks on the right. So you're going to see a sort of trend to a lot of the A's. We're talking about accelerating change, and I mentioned here Jim Highsmith with adaptive and anticipation. So we're going to go through a couple of A's. A really big A is avoid. So this is a huge, if you're trying to accelerate change, of course you want to avoid extra effort. And by doing things like systematic reuse, using open source, for example, you can avoid a lot of overhead. There's no reason for us all to be developing the commodity software, right? I think Jan Bosch has this 3-layer product line ecosystem approach, right? You've got your commodity layer, you've got your differentiating layer, and your innovation layer. There's no reason for us all to be putting lots of effort into reinventing the commodity layer. If you can be aware of that and take that out of, factor that out of the system, you can use your effort to more reasonable things. We also do often a lot of over-engineering, and gold plating on our systems. If we were to know that we maybe don't need all of those features, if we could instrument our system so that we know, feature X, Y, Z are never invoked by the user, well, maybe we could, gradually take those out of the system, not maintain those anymore, and gradually, use that data in the system to improve the next generations of the product so that we don't invest effort into things that aren't being used. There's a huge amount of extra effort done by applying sort of old school methods to these more modern, situations where really more modern management methods should apply. So a lot of handoffs into silos. The requirements folks write their spec, throw it over the wall to the R&D department. If we can get those departments to work better together, there's a lot less overhead in those handoffs. And similar with the devs throwing it over the wall to the ops people. It's a similar situation. If we can get those handoffs to happen in a much smoother way and a lot less effort, get everybody on the same page through transparency and having all a common understanding, then this also saves a lot of effort and it helps to accelerate the change. And doing like risk-based approaches. A lot of the old school says, do inspections, peer reviews, and so on. Think risk-based, which parts of the system you need to do those on. You don't need to do them on everything, maybe. Split your system up into, say, the safety-critical part or the non-safety critical part, and do those on the safety-critical part, for example. Or things like this, and also with the risk-based testing and risk-based for many of these different activities. So you need to focus on trying to focus your effort on where it will really have the most impact. So the next topic is anticipation. This is a little bit the idea that I was talking about before, about how much architecture do you do up front. You need to think beforehand what might happen to the system. And you may want to set up some things in your organization, for example, to expect a certain situation might arise and have a team ready to handle that if that situation comes up. If you have suddenly an emergency situation and you don't have that team set up, then it will take you too long to set that up. And so you may need to consider beforehand what potentially could happen and anticipate that these are going to come. And so you need to have the right mix of prevention and being able to react in a timely manner during the development. So this is why I sort of showed here this crystal ball. You want to look into the future to some extent and to be able to have an idea on what you can prepare for in the future, sort of the Boy Scout motto. Benjamin Franklin, that's one of the U.S. presidents, said, by failing to prepare, you prepare to fail. And so I think this is also an important topic for architects to think long-term, what could be the long-term consequences of this system. What do we need to be prepared for? And perhaps you could also, in the system, set up some kind of alarms. If you're working sort of in the DevOps area, you might want to say, for example, that you want to have some monitoring of the system, that if you notice it gets over a certain performance threshold, that then something happens to be able to ensure that you do not further go past a more critical threshold, for example. And you could set that kind of system up in your product. So this dancing elephant is symbolizing the agile, right? So you have this big, bureaucratic, heavyweight thing, and you're trying to get it to dance or get it to be a little bit more flexible. It's important that the topic of agile and sort of the next trend after agile, in my view, is sort of the next big thing is the topic of DevOps. So agile and the topic of lean, these kinds of ideas, it's a whole cultural change to be able to understand how to apply these kinds of other methods. And as I mentioned before, don't plan the whole product out in detail, but just the sprint that's coming up, and make sure that you apply these methods appropriately. Okay, on the architecture, this is a cute quote. Of course, it doesn't apply to our software, but it says it's from Sam Redwine. Software and cathedrals are much the same. First we build them, then we pray. Okay, so the picture is meant to symbolize working on the trunk, right? It's very, very easy to start a branch, not only in the software architecture, but also in our whole product development. It's easy to say, okay, well, here's this very important customer, we're going to make a branch just for them, and then just a branch for the other, and just a branch for the other, and you get such a variety, and you need to be able to deal with that variety or try to keep it smaller. And the same thing happens in the software architecture, right? You need to, if you're going to be having a more DevOps system, and that's where this is all heading, all of these things are helping in the DevOps space, then you need to try to focus on that one single main trunk. And you want to avoid dependencies, because avoiding dependencies is extremely important for being able to take out particular parts of the system and replace them with others. So these dependencies are not only making the system harder to develop over time, but also the test cases also is good if they are such that you don't have so much dependencies between them as well. And of course, the architecture is really important for the quality attributes and all the the non-functional requirements like scalability and security and performance and safety and so on. So the architecture has to be aware of these topics, and they're really a very first-class citizen. You need to make sure that your architects have enough backing in the organization to ensure these properties, and because they are extremely important. The product management will tend to want to focus on feature, and as architects, you need to have the backing to be able to say, okay, well, we need to also focus on the performance and the scalability and other aspects of the system as well. Things like adaptive partitioning. There are some helpful things happening also in the hardware world. Different processors that allow, like a hypervisor, to separate processes from each other. So these kinds of also physical separation of the processes is also very helpful in this space to allow to ensure that you can have these less interdependencies. This topic, I mentioned it called autonomous because it has an A, but it's not really quite so much the autonomous idea. I think the topic of autonomous systems is also a very important one. But what I'm meaning here is also the idea of having different paces of change on your system. Very similar to what you have with a cell phone, that you might have your Android base system, and then you've got your apps on top of them. And if you structure your system this kind of way, you have a lot of advantages. You could say maybe this app is installed by the end customer at their own risk, and maybe we don't need to do some aspects of that. Maybe we do the assurance and on the main part of the system in a different level of depth than on the individual apps, or maybe the individual apps come from third-party providers, for example, also. And so this kind of structure where you have the main system maybe has a 6-month pace of change, these individual apps could have a much higher pace of change, and separating them in the architecture, as mentioned by this quote here by Brian Foote and Joe Yoder, is a very appropriate architecture technique to keep things that have a similar pace of change together in the architecture. And extremely important for us is this topic of being resilient and failing in a appropriate way. Because as I mentioned in the opening, a lot of times we have systems that are connected to physical processes. And so in some situations it's fine to fail safe and bring the train to a halt, for example. But in other kinds of situations, I imagine if you're in a plane or something, you don't want to bring that to a halt. You need to fail in an operational way. And so you need different techniques to apply. So you need to, of course, consider these kinds of things and to know what kinds of fail safe, fail passive, fail operational, what kind of scenario you have in your system, and have your architecture do that appropriately. So in the area of automation, when we're getting into DevOps, and this is supposed to symbolize a delivery pipeline with a little bit of a knot in it, you have a lot more automation. So we try to have a lot of automated tests, for example, but not all sort of the same kind of automated tests, have a different, not only code coverage and so on, but also tests of the non-functional properties of the system and how different parts of the system work together. So you need to have a whole bouquet of different kinds of test approaches. We work a lot in the area of also model-based testing, which I think is very appropriate. You need to take concern of both the test of the product itself and also the infrastructure. Your whole infrastructure is going to be extremely important here. And second quote from an American president on Abraham Lincoln: "So give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe." And this is the idea behind the delivery pipeline. If it's important enough to do, it's maybe important enough to automate, because this will give you the predictability. I mentioned at the beginning that our approaches that we learn in software engineering university assume sort of you have this predictability, and this is a different way to get predictability. It's much more individualized, a lot more empowerment to the team, but this delivery pipeline is giving us the level of predictability that we sort of strive for on the other hand. I mentioned model-based testing, so model-based approaches, these are the sorts of things that are done by our Siemens PLM software company with the model-based approaches, how to do the digital twin. You have the whole model of the Maserati in the software system. Here's the Maserati itself, here's the model. You can do all the simulation, take it through the wind tunnel, and so on, right? By having this level of abstraction and to apply these model-based approaches, you can have a huge win and also save on producing lots of different prototypes of the system. Analytics is a huge topic coming up. We want to be able to use the data, which features are being used by the customer, but also operational data. Is the system performance, when it's in operation, good enough? How can we take advantage of the data that's also in the development system, as we develop the system? Want to build in a lot of this runtime monitoring, for example. The next 2 A's are more soft topics. This one is on the topic of ability, so the importance of training. I mentioned our architecture training program, our curriculum. It's extremely important to be able to have the persons that are working on these highly complex topics have the appropriate training and have the similar understanding, and to be able to have the different roles have the same understanding. So when we have the training for our architects, we teach them also how to speak to their product managers, and then we also have a similar training for our product managers how to speak to their architects, and it all fits together in this set of core principles that we have in the whole program that is on Agile and Lean, and this is the basis you need for collaboration. I thought this was also a good quote in the area of the importance of training. So better train people and risk that they leave than to do not do it and risk that they stay. Because the people topic is really one of the most important levers that you have. And the people are wanting to do this in the right way, but they need the skills and they need the empowerment to be able to do it. And training is a really big step on that. And it's all kinds of different training. So it's not just in-person training, that's really important, but also training on the job, coaching, networking, activities within the company, and so on. And also the sorts of things that we do in conferences like this, coming together with industry representatives from other companies or from getting new trends from the academia and other research areas. So getting always up to speed, what are the latest trends? And the final topic is the topic of culture. This is actually the largest hurdle that I think is in the area of DevOps and also these more modern approaches. There's a huge culture change. You know, can you imagine then this empowerment that there really maybe could be this impact on the final system? We need to have a culture that allows more failure. You know, failure is sort of like a first attempt in learning, right? You learn much more from a failure than you do from a success in some sense, right? And we need to get away from this sort of finger pointing, blaming each other to this more collaborative team approach. And also working also closer together also with our customers as well. So it's also not just within the company, but also outside. So these are all techniques that are sort of helping us get speed and to accelerate change. So these are all of the topics that we mentioned. And as I mentioned, the topic of DevOps is sort of the next logical step after Agile. And so we're changing from embrace change that I think Kent Beck really propagated with the Agile and XP to more accelerate change. And this is sort of, for us, is sort of the DevOps idea. So getting into DevOps, here, this infinity sign is sort of the symbol for DevOps, where you're trying to bring dev and ops together in a long-term bond that is really infinitely brings these together. And at Siemens, we have a term that we use for applying this DevOps idea in the sort of digitalized industrial world where our home base is. And this is what we call industrial-grade DevOps. So this is DevOps with special requirements, being able to apply in the sorts of business areas that Siemens is active in. Because there's a lot of people doing DevOps in sort of software-only areas, but there's some additional challenges that I hope I've been able to convey to you thus far in our area of work. And this is the sorts of things that we're pursuing in this vision of industrial-grade DevOps. So we want to, for example, have the quality in development, in operations as well. So infrastructure as a first-class citizen, full transparency, all these kinds of DevOps things in our world. And we're truly trying to break down with the DevOps the wall between this dev and this ops. And you know the famous quote by Ronald Reagan in Berlin, you know, tear down this wall. That's what we're trying to do here, right? So this is an external-facing slide on the area of DevOps. It's sort of showing how, like Amazon and other IT and software-only companies, or also some retail and finance companies, are now in this sort of cycle time of seconds, minutes cycle time. You know, more industrial companies in the sorts of areas that we're in, we're still more in this, you know, monthly, quarterly release, but we're all trying to move over to the right. We're trying to get much faster. But of course, we have additional constraints that we need to apply in our business. So, but everybody's sort of moving shift right. This is an overview of our approach. Some of you might know from the Software Center or the Stairway to Heaven. This is quite similar approach. We have continuous build and integration and test down here in these bottom two levels. This is, you could imagine this being sort of basically the agile approach. And we're wanting to get more into continuous delivery. That means the ability to deliver to the end customer, including things like the assurance that we may need to have for safety critical systems, for example. We have a lot more challenges to do here than the software-only companies. It's still a business decision then whether to actually release and deploy the system here, where it actually goes over the edge into the operations, and then even further into this continuous operation. This is what we call a fluid products, that we might have at some point in the future a product that is out in the field and it gets updated while it's still out in the field. That's sort of the vision behind this. And so we're on the way. This is some of the definitions of how we interpret each of those terms, because it's not actually a consistent understanding in the external world what is delivery, what is deployment in this continuous space. So it was better to include our definitions of this. This is a slide showing the challenges in this area. So there's a huge, I guess you'd say, a bouquet of challenges to address in this space. They range. We like to often structure our topics according to sort of business-oriented topics. That's these green ones. More process and operations aspects. That's the orange. And more technology-focused ones. Those are the ones on the blue on the right. And so there's a whole range. This is just sort of the structure of how we address the challenges, because what we work and do, how we operate in the projects that I'm involved in, we try to structure all of the large number of challenges that we have in this space, and then try to find solutions to mitigate each of them. So things like the culture issue is here. How do you adjust the processes to be able to work in such a way? You've got the product technology, but also the environment technology to have your appropriate infrastructure in place to be able to do this. And then in these sort of onion shapes here, how do you, this simple case is down here in the middle, where you have maybe a cloud-based solution. And then you may have other additional challenges that also actually apply in this whole range here. How do you do this in regulated environments? If you're in the healthcare space and you need like FDA approval and you're trying to do DevOps, you still have all of these challenges to somehow address. Or if you have your systems are out in the field, already installed at the customer base, and you're trying to update them, you also have a whole range of challenges. And similar for embedded systems if it's not software only. And so this is the structure we use to address the challenges in our projects. I have two slides getting into the closing now on Tesla, because I mentioned here regulated environment, embedded systems, systems out in the field. Those are actually challenges that I think also Tesla has. And Tesla has a long history of over-the-air updates of software. And it can be on one side in the infotainment kind of space, that your maps and so on are updated, but also, and that's where it gets into updating the maps, that would be examples of being in the field, right? These systems are out in the field and being updated, but also they're in the area of regulated that I mentioned also, because they are subject to the road safety requirements, for example, in their autopilot topics. And so these are two slides actually just from the Tesla webpage, that they regularly have these updates, and they're now they do them, I think, every 3 times a year, something like that. So they're not like daily updates, but they are seen by their customers as a valuable topic, that their car the next day has some of these updates in it. And these are the sorts of things that they do. They do the maps, of course, but they also do other things, like they have this cabin overheat protection, where they actually ensure that the car does not overheat. If, for example, a child or a pet or something might be in the car, that they'll automatically detect that and adjust the temperature of the car. So really also a physical process to avoid that car overheating. And also here the autopilot. So they update also these kinds of things. And so that's an example of a company where we like to look at to see what kinds of ideas are they addressing and how are they addressing them, and to try to bring those ideas into our space. So here I have a closing slide sort of showing we have these end-to-end life cycle, and we try to encourage that we have much, much faster feedback cycles. And you can see here visually, oops, sorry. So you can see here visually how the cycle times automatically get faster when the things come together. And maybe one last quote. I mentioned three American presidents. I guess you're wondering why I haven't mentioned Trump yet. But so I do have a quote from Trump. You saw this big bouquet of challenges that we have, and it's really a great, huge challenges that stand before us, and we're really highly motivated to address these huge challenges. And in The Art of the Deal, Donald Trump says, "You have to think anyway, so you might as well think big." Thank you.
Yeah, good. Thank you very much. We have a few minutes for questions. Since they don't think fast, so I will ask you. You know, it's very easy to do this daily deployment and integration on software, but if you have complex systems, so how deal with that? I mean, the Tesla, it's still the same car. You don't change tires.
Yeah.
And
Yeah, well, that's a good point. I mean, I think really that we need to have these different pace of change, right? The software could change much faster, and then for things that are involving hardware, our idea is that you could have sort of a separate cycle around that has a different pace of change, where maybe also, it's yet another the assurance topic, right? If you need to check that something is safety critical or so on, or check the security or safety, for example, of the system. In these larger pace of change, you could build something in, and you need to increasingly be able to do that in a sort of a delta consideration. So you do up front maybe your main model of the safety, and then when you add some new feature, you just do the delta, what's the change impact analysis of adding this one feature. And if you have that all modeled, then it's easier to check, does this one small change have a small effect? You don't have to do the whole model again, or you can do that in an automated way.
But how do people which are like system engineers, classical, in other words, mechanical engineering, so accept these concepts?
They're hard to convince. Yeah, they're hard to convince, but I think it's an art to find the right ones, right? They're sort of leaders of the pack in there, and you need to find the right leaders of the pack and know who are the positive ones and who are the naysayers, and it's sort of an art to get the right people. You need to maybe even bring some of the known naysayers into the fold and have them on your side and try to do it that way. But I think the same sort of techniques apply in almost any kind of thing. It's more of a social approach. Yeah.
So this culture, which you
Yeah,
mentioned.
and
Okay.
it's hard sometimes to convince the management also, because a lot of times you hear, well, maybe the customers aren't ready yet for these deliveries so often. But you need to sort of show the opportunities that there may actually be a different business model behind it. You know, maybe one can subscribe to the regular updates and so on, and there's maybe less service visits to the customer because we can do it over the air or through the cloud or some such. So we need to make sure to convince not only the technology folks, right? I mentioned business process technology. We need to convince them sort of simultaneously on all three levels. Make sure we've got the business case in place, and the processes that can handle it, and the technology.
And the other things, I know Jan Bosch used to say that he is like the happiest when he knows that the next day his car will be updated by new software. But I don't think all people will be happy like that. So what is about your customers? Do they like these updates or not?
Yeah, well, I think it's a little bit too early to say. I think we have to certainly take care of that approach. And but I think we always have a broad range of customers, and thus far I think we've been pretty good about being able to have the appropriate solution for the various ones. So I'm confident that we'll be able to address that as well.
Okay. In the case for yes, one question there. Okay. So some.
Thank you. It was a very interesting talk. You've clearly got a very wide range of customers across a lot of contexts. have you got any feel for which of those contexts are most willing to accept this dynamic change, and which of those are real challenges to persuade?
Well, I think the ones that are in the non-regulated are surely the easier ones to sell, right? They're going to be more interested in having a cloud-based approach. So I think the regulated industries are going to be the hardest ones to convince. And I think even on the cloud ones, we need to also be very careful, and we are very careful regarding the privacy situation, right? And having the right cloud providers that are like only in Europe or only in the US and so on. So we have to address these kinds of issues. But I think we have had a good experience in convincing the customers in this space. Yeah.
Okay.
Okay.
So
Okay.
thank you very much.
Yeah, well, thank you.
And looking forward to hear again. So this is a
Thank you.
Thank you.
Thank you. Thank you very much. So.
Okay, now it's a coffee break.
Ask me in the break also if you like. Yeah?
Yes, definitely. You have chance to ask.